In this video, I'm going to talk about some of the multiple choice the questions. So the first problem is, and this is from the chapter Force and Motion. So even if you are taking the university physics or the college physics, this is for all the students. So the first problem is, if you have an object and you want this object to move, you must push harder onto than it pushes back to you. Is it true or false? It's false. Why? Because if you push something with more force, it will push back with you the same force. It's from the Newton's third law of motion. Okay, the force, the action and reaction are always equal and opposite. So this will be the false. Whenever you push an object harder, it will push back to you again harder. Okay. So the second problem is, a student is in an elevator on the ground. His weight is 615 Newton, and in an elevator he reaches 645 Newton. Can you tell the information that the elevator is moving up or down? So in order to solve this problem, you need to know the Newton's second law of motion. What does the Newton's second law of motion tell you? Okay, let me explain this problem now. So if you take a Newton, let's say you have an elevator, okay, and this one is going up. The weight is always downward. So this is for the up motion. So the weight is always downward, and this is for the down. The weight is again downward, mg, and the tension in the spring is upward. And the acceleration, as it is going up, so this is an acceleration A, and this is going downward, so this acceleration is A. And I'm using the Newton's second law of motion. So if this is going up, I'm going to use F is equal to ma. Remember, what is F? The F is the total force, the net force, and this is going up, so this force along the direction of motion is T minus mg. This is equal to m times A. So what I can say about this one, the tension is equal to mg plus A. Okay, so the tension gives you the apparent weight, and in this case the F net is equal to mass times acceleration, and this is equal to mg minus t, because as it is moving down, so you have to take all the forces in the direction of the motion. So here you have mg minus t is equal to ma, and the tension is equal to mg minus a. Okay, so this is for the upward motion and this is for the downward motion. And now you see the weight, the student weight was 615, but when it is in an elevator on the ground, but in an elevator he reaches 645 Newton. That means his weight has increased. The only way, if this is positive, then then his weight can increase. But here you see, if the acceleration is positive, the weight would go down. But this is but there is a possibility that the accelerator, the elevator would be slowing down. The acceleration could be negative. So even if the elevator is going down, the tension or the apparent weight can go up, And this happens when the elevator is slowing down while going in the downward motion. If the elevator is slowing down while it is going down, then this tension can go up. Or in other words, if acceleration is negative, if a is smaller than 0, then t may go up. And here, if the acceleration is again negative, then t may go down. So you do not know, just from this information, it is hard to tell. You cannot tell it whether it is going up or it can go down. Even if it is going down, and if this acceleration is positive or if this acceleration is negative, then the tension may go up. While it is going up, you see, if this is positive, yes, of course the tension will go up. But if this is negative, then it may go down. So you cannot tell it. So on number 3 problem, you have a truck which collides with the car. And then during a collision, which one exerts more force? According to Newton's third law of motion, the truck and the car during the collision exerts equal amount of force. Okay, so if you have a truck, this is a big truck here, and this is a car. When they collide, they exert equal and opposite amount of force. So the force on each of them should be equal. So the correct answer is the number B. The force on the truck to the collision is exactly equal to the force on the car. So this is a pretty simple problem. So for number 4 problem, so you have a fish which is weighing 16 Newton. So this is 16 Newton. Okay, and then you have 2 scales here, 2 spring scales. Which one would read more, or there would be any difference on the reading? No, the reading would exactly be the same. Okay, let's think this way. The weight is downward, so this fish exerts a force onto this spring downward, and this spring again exerts the same amount of force onto this spring. So, and we of course ignoring the weight of the spring. So if the spring is very, very light, so the reading on each spring would be exactly the same, just by the Newton's third law of motion. Okay, so this fish has the weight which is downward, and it tries to pull the spring downwards, and this spring will again pull the downward with exactly the same force. Of course, be ignoring the mass of the spring.